Voyager 2's final transmission did not end with silence. For nearly half a century, the small spacecraft had done exactly what it was designed to do. It traveled, it measured, and it whispered its findings across billions of miles of vacuum. Even as its power systems weakened and instruments were shut down one by one to conserve energy, the signal itself remained predictable. It was faint and delayed by more than 18 hours each way, but it was steady and reliable. The final coherent packet of data arrived like all the others, weak and compressed, stretched thin by unimaginable distance. Engineers at the Deep Space Network expected routine plasma readings from interstellar space and standard measurements of cosmic radiation. Instead, buried inside the static, they noticed a pattern that did not fit with previous observations. It was subtle at first, easy to dismiss as interference or instrument drift. But as analysts looked closer, the structure within the noise became harder to ignore. To understand why that matters, you have to remember what Voyager 2 represents. Launched in 1977, it was never designed to operate for nearly 5 decades. Its onboard computer is less powerful than the simplest modern smartphone, and its memory capacity would seem almost non-existent by today's standards. Yet it carried out one of the most ambitious planetary explorations in history, flying past Jupiter, Saturn, Uranus, and Neptune, sending back data and images that transformed our understanding of the outer solar system. After completing its planetary tour, Voyager 2 did something even more remarkable. It kept going. It headed toward the invisible boundary of the heliosphere, the immense bubble carved into interstellar space by the solar wind. Inside that bubble, the sun's influence dominates the behavior of charged particles. Outside it lies the interstellar medium, the vast region between stars filled with sparse gas, magnetic fields, and high-energy cosmic rays. In 2018, instruments aboard Voyager 2 detected a clear shift in particle density and magnetic field orientation, confirming that it had crossed the heliopause and entered interstellar space. This was not a dramatic visual crossing, but a gradual transition measured through changes in data. Solar particles decreased sharply, while galactic cosmic rays increased, signaling that the spacecraft had moved beyond the sun's protective bubble. Conditions in interstellar space are extreme and counterintuitive. The vacuum is so thin that a single cubic centimeter may contain far less than one atom on average. Despite the low density, particles can carry immense energy, and magnetic fields thread through space in vast, invisible structures stretching across light years. Shockwaves from distant stellar events can travel silently through this medium for centuries before dissipating. It was within this environment that Voyager 2 sent what would become its final coherent transmission. Engineers reviewing the dataset noticed rhythmic fluctuations in plasma wave readings. Initially, these variations were attributed to potential instrument aging or background interference. However, the oscillations repeated with a consistency that suggested an underlying structure rather than random turbulence. The data appeared to indicate that Voyager 2 had encountered a region of slightly higher plasma density, possibly a filament or boundary created by interactions between interstellar magnetic fields and the fading influence of the solar wind. Such structures are predicted by theoretical models, but have rarely been measured directly. If confirmed, this would mean that interstellar space is not uniform, but contains textured regions shaped by dynamic forces. After the anomalous readings were identified, mission controllers transmitted commands to recalibrate instruments and verify system status. Because of the immense distance, each exchange required more than 18 hours for the signal to travel one way. The team waited patiently for a response, monitoring the faint carrier wave for signs of stability. Instead of a clear reply, the signal weakened. The carrier wave flickered intermittently before dissolving into background noise. Attempts were made to boost receiver sensitivity and adjust antenna alignment within the Deep Space Network's facilities in California, Spain, and Australia. Despite these efforts, no further coherent telemetry was recovered. The silence itself was not entirely unexpected. Voyager 2's power source, a radioisotope thermoelectric generator, has been gradually losing output since launch. Engineers have carefully rationed power for years, shutting down heaters and non-essential instruments to extend the mission. Eventually, the transmitter was always going to fall below the minimum power threshold required for communication. What unsettled observers was the proximity and timing between the unusual plasma readings and the loss of signal. While there is no evidence that the two events are causally connected, the coincidence has fueled speculation and intense scientific scrutiny. Statistically unlikely patterns draw attention, even when natural explanations remain the most plausible. The most probable interpretation is that Voyager 2 detected a density wave or magnetic structure in the interstellar medium, perhaps influenced by past solar activity or distant astrophysical events. Similar waves have been observed by Voyager 1, suggesting that the outer boundary of our solar system interacts dynamically with its galactic surroundings. These interactions may produce regions of compression and turbulence that were previously underestimated. Regardless of the precise explanation, Voyager 2's final data contributes to a growing understanding that interstellar space is not an empty void, but a complex and evolving environment. The spacecraft's measurements refine models of how stellar winds interact, how cosmic rays propagate, and how magnetic fields shape the space between stars. Even incomplete data can influence decades of theoretical work. Somewhere more than 12 billion miles from Earth, Voyager 2 continues its outward journey at tens of thousands of miles per hour. It likely remains structurally intact, drifting through darkness long after its voice has faded. Bolted to its exterior is the Golden Record, a time capsule containing sounds, music, and greetings from Earth intended for any intelligence that might encounter it in the distant future. The end of communication does not mark the end of its mission in a symbolic sense. Voyager 2 has already exceeded every original expectation. It has extended humanity's reach beyond the solar system and demonstrated that even modest technology, guided by careful engineering and persistence, can achieve extraordinary distances. Its silence serves as a reminder of both achievement and limitation. Radio waves weaken with distance, power sources decay, and machines eventually fail. Yet the knowledge gathered endures, stored in archives and woven into scientific understanding. Voyager 2's journey reshaped planetary science and opened the field of direct interstellar exploration. In the coming decades, new probes may follow, equipped with advanced propulsion systems and longer-lasting power supplies. They will build upon the path Voyager 2 carved through space. The final transmission does not confirm catastrophe or cosmic threat. It confirms something quieter and more profound. Exploration pushes outward until technology reaches its limits, and then it inspires the next leap forward. Voyager 2 now travels beyond our hearing, but not beyond our story. It remains a moving artifact of human curiosity, carrying evidence that we once looked at the stars and chose to send a part of ourselves into the dark. That choice, made in the late 1970s at the height of geopolitical tension and technological rivalry, now feels almost poetic. A machine assembled with slide rules, early microchips, and hand-tested components has traveled farther than any other active emissary of humanity. It was designed during an era when computers filled rooms and data was stored on magnetic tape, yet it has outlived entire generations of more advanced hardware. The fact that it functioned for so long is not mysterious. It is a testament to careful engineering, conservative design margins, and a mission team that refused to give up on it. The Deep Space Network, the global array of giant radio antennas that kept Voyager connected to Earth, represents another quiet triumph. These dishes, positioned in California, Spain, and Australia, rotate slowly to track a signal weaker than the energy used by a refrigerator light bulb. By the time Voyager 2's transmission reaches Earth, it is billions of times fainter than when it left the spacecraft. Extracting data from that whisper requires extraordinary precision, filtering cosmic noise from meaningful information bit by bit. When the final signal degraded, it did so gradually. There was no dramatic cutoff, no sudden extinguishing. Engineers describe it as a diminishing coherence, a spreading of the signal into randomness. The transmitter likely dipped below the minimum power threshold needed to maintain stable communication. Without sufficient voltage, even a perfectly functioning antenna cannot hold its structure in the electromagnetic spectrum. The universe simply swallows the signal. And yet, the data received just before that fading continues to be examined in detail. Plasma wave instruments convert variations in charged particle density into frequencies that can be analyzed, almost like sound. In previous years, similar instruments on both Voyager spacecraft detected shock waves from solar eruptions that took years to travel outward. Those readings allowed scientists to estimate the density of the interstellar medium more accurately than ever before. The final oscillations recorded by Voyager 2 may represent another such wave, possibly triggered by solar activity from years prior. As solar storms expand beyond the heliosphere, they can compress interstellar plasma, creating temporary regions of higher density. When Voyager passes through these regions, its instruments register a measurable change. The structured pattern in the last transmission may reflect that interaction, a final data point capturing the ongoing dialogue between our star and the galaxy beyond. Understanding this interaction is not merely academic. The heliosphere acts as a partial shield against high-energy cosmic rays, which can pose risks to astronauts and electronic systems. If the boundary of that shield is more dynamic or irregular than previously thought, it influences long-term planning for deep space exploration. Voyager 2's final readings therefore contribute to practical considerations about humanity's future in space. There is also a philosophical dimension that cannot be ignored. For decades, Voyager 2 was a living thread connecting Earth to interstellar space. Its silence forces a shift in perspective. Instead of active communication, we are left with legacy and trajectory. The spacecraft continues moving outward, but it has become an artifact rather than a correspondent. In roughly 40,000 years, Voyager 2 will pass within a few light years of a star in the constellation Andromeda. Long before that encounter, Earth itself will have changed beyond recognition. Continents will drift, climates will shift, civilizations will rise and fall. The golden record attached to Voyager 2 may still exist, carrying encoded images of DNA, mathematical definitions, greetings in dozens of languages, and music from multiple cultures. It was never likely to be found, but it symbolizes optimism, the belief that even in the vast silence of space, connection is possible. The final transmission, rather than confirming a cosmic threat, underscores a different truth. Space is not empty in the simplistic sense we once imagined. It is structured by magnetic fields, stirred by shock waves, and shaped by interactions between stars. Voyager 2 provided direct evidence of that complexity. Even in its last measurable moments, it expanded the frontier of knowledge. The emotional response to its silence reveals how deeply people identify with exploration. Voyager 2 is metal and circuitry, yet it feels almost alive because it represented continuity. It was a steady presence in the background of scientific progress, a reminder that human curiosity can extend far beyond immediate horizons. When that presence fades, it feels like the closing of a chapter. But chapters close so others can begin. New missions are already being designed with lessons drawn from Voyager's longevity. Engineers are studying advanced propulsion concepts, more efficient power systems, and autonomous navigation that could allow future probes to operate for centuries. The dream of sending a dedicated interstellar probe capable of traveling significantly faster than Voyager remains active within scientific communities. If that mission launches in the coming decades, it will trace part of the path Voyager 2 pioneered. It will move through regions whose plasma densities and magnetic structures were first sampled by this aging spacecraft. In that sense, Voyager 2's silence does not mark an end, but a transition from exploration to foundation. Somewhere in the darkness, far beyond the orbit of Neptune and the scattered remnants of the Kuiper Belt, Voyager 2 continues forward. Its systems are cooling, its instruments are quiet, its antenna no longer beams data toward Earth. Yet its motion persists, governed by the same gravitational laws that shaped its slingshot past giant planets nearly 50 years ago. The universe has not confirmed disaster or hostility. It has confirmed scale. It has confirmed that distance eventually overcomes even our most determined efforts to communicate. And it has confirmed that even a small machine built in an earlier technological age can push the boundary of what is known. Voyager 2's final transmission may have been faint and fragmented, but it carried one last insight about the nature of interstellar space. Then it yielded to silence, not as a failure, but as the natural conclusion of an extraordinary journey. The spacecraft now belongs entirely to the galaxy it helped us understand, drifting onward as a silent witness to humanity's first step beyond the sun's embrace. Even in silence, Voyager 2 continues to inspire. Scientists and engineers analyze its last data in laboratories, translating faint plasma oscillations into maps of interstellar structure. The subtle variations in particle density, once hidden within billions of miles of space, now reveal the contours of a region previously unknown to humanity. Every measurement taken, every oscillation recorded, contributes to a more detailed understanding of the boundary between our solar system and the galaxy beyond. Voyager 2's legacy is therefore not measured solely in miles traveled or years of operation, but in the knowledge it delivered and the questions it continues to provoke. The story of Voyager 2 also serves as a lesson in patience and perspective. Every command sent and every byte of data received took almost a full day to traverse the immense distance. Researchers learned to work on cosmic timescales, to interpret signals that arrived years after the events they recorded. The spacecraft has forced humanity to expand its conception of time and distance, teaching that even tiny signals can carry immense significance when they come from the edge of the known. Beyond the science, there is a symbolic dimension. Voyager 2 was humanity's first tangible attempt to reach beyond the solar system with purpose. Its golden record was an offering to the cosmos, a declaration of presence, a statement of hope that another civilization, someday, might listen and learn about us. That record continues its journey independently, a silent testament to what humans can create when imagination and engineering converge. Even if no one ever finds it, it represents an enduring optimism about connection across unimaginable distances. The spacecraft's passage through interstellar space highlights the fragility and resilience of human endeavor. Voyager 2 operates with a fraction of the computing power in modern smartphones, yet it completed missions that required precision, endurance, and ingenuity. Its success demonstrates that longevity and impact are not only products of advanced technology, but of foresight, careful planning, and iterative problem solving. Every shutdown of an instrument to conserve power, every calibration made from Earth, extended its life and expanded the frontiers of exploration. The final transmission also emphasizes the limitations inherent in reaching into the cosmos. Even as it traveled beyond the reach of the sun's influence, Voyager 2 could only communicate intermittently and eventually not at all. This boundary is both literal and metaphorical. The farther humanity reaches, the weaker our grasp becomes, and the more we confront the vast, indifferent expanse of the universe. Voyager 2's fading signal is a reminder that exploration is not always about immediate reward, but about enduring curiosity and the courage to venture into the unknown. There is a quiet poetry in that reality. The spacecraft drifts onward through darkness that no human has ever witnessed firsthand. It carries the sound of our voices, the images of our world, and the imprints of our civilization, even as it moves into regions where no eyes can see it and no ears can hear it. That silent journey mirrors the trajectory of human curiosity itself, persistent, patient, and far-reaching, even when acknowledgement is impossible. As Voyager 2 moves further into the unknown, its data continues to shape plans for future missions. Scientists study the spacecraft's trajectory and measurements to refine models of interstellar space, improving our understanding of radiation hazards, magnetic turbulence, and particle interactions. Engineers draw lessons in durability, energy efficiency, and instrument longevity, applying them to probes designed to travel farther, faster, and with greater autonomy. In this way, Voyager 2's influence extends far beyond its physical presence, shaping the next generation of exploration even in silence. Ultimately, Voyager 2 embodies a paradox. It is both profoundly distant and deeply connected. Though billions of miles separate it from Earth, the spacecraft continues to inform our understanding of the universe. Though its transmitter has failed, the journey it undertook and the legacy it leaves are unmistakable. Every measurement it sent, every planet it revealed, every ripple in plasma it recorded contributes to a narrative of curiosity, perseverance, and the human desire to comprehend the cosmos. The final transmission may have been faint, incomplete, and fragmented, but it serves as a fitting conclusion to decades of discovery. It reminds us that exploration is not about guarantees or comfort, but about risk, patience, and the pursuit of understanding. Voyager 2 went further than anyone could have imagined, and even now, as it drifts through interstellar space in silence, it remains one of humanity's most profound achievements. A reminder that the universe is vast, complex, and waiting to be understood. Voyager 2's journey continues, even if we cannot hear it. Its story is now part of the larger story of humanity's search for knowledge. In its silence, it calls us to look upward, to imagine, and to continue the pursuit of discovery. The spacecraft's motion through the cold reaches of space is a testament to the enduring power of human ingenuity and ambition. It is a monument not built of stone or metal, but of curiosity, perseverance, and the persistent desire to reach beyond what is known. Even as its voice fades, Voyager 2 speaks in every discovery it enabled, every model it refined, and every mission it inspired. The spacecraft will continue its silent passage through the galaxy for millions of years, carrying with it our presence, our questions, and our hope that the human story can extend beyond our fragile planet. It leaves behind a universe made richer, more textured, and more mysterious, and it challenges us to continue exploring with the same boldness and patience that carried it to the edge of interstellar space. The final transmission may have been Voyager 2's last direct communication with humanity, but its influence is eternal. Every oscillation, every ripple in the plasma it recorded, every faint signal sent over billions of miles reminds us that the universe is vast, alive with subtle structure, and that our curiosity can reach farther than our immediate senses. Even in silence, Voyager 2 continues to teach, inspire, and beckon us forward into the unknown. Humanity may not be able to hear it anymore, but Voyager 2 continues onward, a lonely yet enduring witness to the cosmos, carrying the story of our species into eternity. It is a silent messenger, a testament to exploration, and a reminder that even the faintest signal can carry profound meaning across the vastness of space. The spacecraft's voyage continues beyond our perception, but its legacy remains in every mind, every heart, and every endeavor inspired by its journey. Even as we reflect on Voyager 2's fading signal, we are reminded that exploration is never truly complete. Every boundary crossed, every limit extended, opens new questions and new possibilities. The spacecraft's silent journey compels humanity to imagine further, to strive for more, and to continue the quest for knowledge across the stars. Its final transmission is a signal not of an ending, but of an enduring invitation to continue venturing, to continue learning, and to continue reaching into the unknown with courage and curiosity. Voyager 2 now drifts through the darkness of interstellar space, alone yet remarkable, carrying within it the essence of humanity's first reach beyond the solar system. Though the signal is gone, the lessons remain, the legacy persists, and the story of Voyager 2 will continue to shape exploration, inspire generations, and remind us that even the faintest whisper from the edge of space can illuminate the boundless complexity of the universe. Its final transmission, in all its subtlety, confirmed that humanity had extended its reach farther than ever before. It reminded us that the universe is not silent, but alive with structure and motion that we are only beginning to comprehend. And it left us with the most profound understanding of all, that the journey of discovery is continuous, unending, and eternal, just like Voyager 2's voyage through the stars. Even now, billions of miles away, Voyager 2 continues its passage, a small, enduring testament to human ingenuity, curiosity, and the courage to push beyond the limits of the known. In silence, it teaches us the most important lesson of all, that exploration, even when unseen and unheard, is never wasted, and that every journey into the unknown carries the possibility of revelation, wonder, and hope.